So the 7 steps of the formal test for independence. So the chi-square test for independence. Step 1, we are basing our test off the assumption that these things that we're investigating are independent, meaning that they do not affect one or another. So that means in our case, we're assuming that gender and whether or not you went Black Friday shopping is independent. We call this the null hypothesis. So the other notation here, H sub 0, HO, the null hypothesis, okay? We are always stating that these two things are independent. That is the assumption. The alternative to our original hypothesis would be the alternative hypothesis. And this is simply saying that these two things are not independent. So I always start off my chi-square test with just stating those two statements. My null hypothesis for ours is one's gender and whether or not they went shopping on Black Friday are independent. And then my alternative to that would be that it's the exact same sentence except using the word not independent. Okay, so the relationship we're investigating with this test is whether or not these two things are independent. So again, that is the assumption, right? We're trying to show that they are, but we also might end up showing that they are not independent, that there is some connection between those two things. Okay, so that's the step 1. Step 2, calculating our degrees of freedom. So degrees of freedom, that's what this little DF stands for, degrees of freedom. Okay, and the way I do that is with this little formula. And this formula says take the number of rows minus 1, so R minus 1, times the number of columns minus 1. So notice I have 2 rows, 2 columns. So 2 minus 1 times 2 minus 1 ends up being 1 times 1, which is just 1. So I have 1 degree of freedom. And that's important for us to know so that we can identify our critical value later on here. Okay? Now, this will come up later, but if we only had 1 degree of freedom, we would actually have to modify our calculation a little bit, but we'll talk more about that later in this part of the unit. Okay? So, step 3, state the significance level required. There are 3 common significance levels, 10, 5, and 1%. So these basically are telling you how certain can you be of your outcome. And it's kind of the inverse of what we actually state. So notice how 10%, 5%, 1%, this is saying how likely a result is due to chance. The most common level used is the 5%. But here's what that means. It means 95% chance of being true, right? That our findings, right? So our findings have a 95% chance of being true if we select a 5% significance level. With the 10% chance, right, or 1% rather, we would have a 99% chance of our results being true. So the smaller the significance level you choose, the more probable that our results are true. Okay, so we have to select a significance level. In a question given to you on a quiz or an exam, you would be given, right? You would be given the significance level or the critical value. So keep that in mind. But as we continue on here, there are a couple things we need to know to make sure we can identify the critical value. So in this example, we're going to choose a 5% significance level. So in step 3, we just want to make sure we state that. State significance level of 5%, right, for step 3. So again, that's going to tell us that our results have a 95% certainty that our results are true. Now, here's why we needed the degrees of freedom and the significance level. And that is so we can identify the critical value, right? The critical value comes from a chart, as you can see on your note page or on the screen right now. We have to know the degrees of freedom and the significance level to identify the number that we're going to compare our own calculation to. So for our example, we have 1 degree of freedom and we chose a 5% significance level. So that means my critical value is 3.84. So this statement for step 4, we call this the statement, the rejection inequality. We are going to reject the null hypothesis if our calculation, which we haven't done yet, is greater than this critical value. So for us, we reject the null hypothesis, right? So reject the null hypothesis, H sub O, if our calculation, which again we haven't made yet, is greater than 3.84. Okay, so that 3.84 is what we're going to compare our calculation to in order to determine whether or not there is a relationship between these two things or not. So step 5, we are now going to calculate chi-squared, and this is where that table comes in to help us calculate this whole formula step by step. So this will be a time in the video where I'm going to move kind of quick, but go back, pause, and just make sure you double check where I got these numbers from. So first of all, in this table, I'm going to set up, notice I have some notation here, F sub O and F sub E. This is the observed. These are the expected values. And those values correspond. So in our observed table, I'm just going to copy those down. So starting at 55 to 70 to 60 to 65. So I'm just going to copy those down in that table. And then that means from my expected table, right, I'm going to copy the same values down in the same order as I went in my observed table. So those values correspond. So my expected values that correspond to each of those observed are 57.5, 67.5, and so on. Now, the rest of this table is just taking one step of the calculation at a time. I'm first going to look at the difference between the observed and expected. Okay, so 55 minus 57.5, that's negative 2.5. 70 minus 67.5, that's 2.5. 60 minus 57.5 and 65 minus 67.5, there is the difference of each observed and expected value. And then I'm going to take each of those values and square them. So notice how I'm just taking that previous column and squaring it. I shouldn't have any negative numbers in this column. When you square something, they're all positive. And now that last step, or that last column, is taking each of these values, each of the values that were squared, and dividing by the corresponding expected value. So I'm making a comparison to the expected value. So 6.25 divided by 57.5 is 0.108, so on and so on. So each of those values, I end up with some decimals. And then at the very bottom, I end up with the sum. And that's my final calculation here, the sum of all of these values. So the sum of all of those values ends up being 0.402574, so on, so on, so on, which to 3 sig figs would be about 0.403 to 3 sig figs. So that's our calculation, and that's the number I'm going to compare to what we had found previously in our critical value, right? So in our case, if our critical value, right, so step 6, this is where we can actually make a comparison. We reject the null hypothesis if our calculation is greater than 3.84. Okay, so think about that. Since our calculation is 0.402574, that is less than 3.84, we say we fail to reject. We fail to reject. That is a fancy way of saying we accept the null hypothesis. We have failed to show that the null hypothesis is false. Okay? So we accept the null hypothesis, which means for us, that means gender and whether or not a person went Black Friday shopping are independent variables. Again, we can be 95% certain that those results are accurate. Step 7, real quick. Step 7 is comparing the p-value, and we will take a look at the p-value when we use our calculator. The p-value we really only calculate that with our calculator, but we have another pair of inequalities that we can use to help us determine whether we accept or reject the null hypothesis. And we'll do more with that as we continue on here. So take a moment. If you need to go back and re-watch some of this video, it's pretty quick, but we'll be getting through a lot more examples here in the next few class periods.